Have you ever wondered why things move the way they do? Why does a ball thrown into the air eventually fall back down? Why do planets orbit stars in predictable patterns? The answer lies in the fundamental laws of physics. Physics is the study of the universe and everything in it, from the smallest atoms to the largest galaxies. And just like any game, the universe has rules. We call these rules the laws of physics. These laws govern how objects move, interact, and behave. Understanding these laws helps us make sense of the world around us. These laws are not just some abstract concepts confined to textbooks. They are at play all around us, every second of every day. From the way your coffee cools down to the way airplanes fly, physics is behind it all. By understanding these laws, we gain a deeper appreciation for the beauty and complexity of the universe. We can also use this knowledge to develop new technologies and solve some of the world's biggest challenges. Let's start with the first law of motion, often called the law of inertia. This law, formulated by Sir Isaac Newton, states that an object at rest will stay at rest and an object in motion will stay in motion at the same speed and in the same direction unless acted upon by an unbalanced force. This might sound complicated, but it's actually quite simple. Think about a book lying on a table. It will stay there forever unless something pushes or pulls it. That's inertia. Now, imagine you're on a bus that suddenly stops. You lurch forward, right? That's inertia too. Your body was in motion and it wanted to stay in motion. The seatbelt provided the unbalanced force to stop you. Newton's second law of motion tells us how the motion of an object changes when a force is applied. It states that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. In simpler terms, this means that the harder you push something, the faster it will accelerate. It also means that heavier objects require more force to move the same distance as lighter objects. Think about pushing a shopping cart. The more force you apply, the faster it accelerates. Now imagine pushing a car with the same force. The car will accelerate much slower because it has a much larger mass. Newton's third law of motion is all about balance. It states that for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force back on the first. These forces always act on different objects and never cancel each other out. Think about jumping on a trampoline. You push down on the trampoline action, and the trampoline pushes back up on you with an equal force reaction, propelling you into the air. Section 5. Newton's laws in action, from rockets to roller coasters. These three laws of motion are not just theoretical concepts, they are the foundation of our understanding of motion in the universe. They explain why rockets launch into space, why cars need brakes, and why roller coasters are so thrilling. For example, a rocket launches because the burning fuel inside creates a powerful downward force or action. This force pushes against the ground, which pushes back up on the rocket with an equal and opposite force or reaction, propelling it upwards. On a roller coaster, the initial climb uphill builds potential energy, which is then converted into kinetic energy as the coaster races down the track. Newton's laws help us understand the forces at play, ensuring a safe and exhilarating ride. Section 6. The elegance of simplicity, unifying principles. What's truly amazing about Newton's laws of motion is their simplicity and elegance. With just 3 laws, we can describe and predict the motion of objects from the smallest particles to the largest celestial bodies. These laws provide a unifying framework for understanding the universe. They tell us that the same laws that govern the motion of a ball falling to the ground also govern the motion of planets orbiting a star. This universality is what makes physics so powerful and compelling. It allows us to make connections between seemingly unrelated phenomena and to appreciate the underlying order of the cosmos. Section 7, Beyond Newton, a glimpse into modern physics. While Newton's laws of motion are incredibly powerful, they do have limitations. As we delve deeper into the realms of the very small, like quantum mechanics, and the very fast, such as special relativity, we find that Newton's laws break down. However, these limitations do not diminish the importance of Newton's work. Instead, they highlight the ever-evolving nature of science and our quest to understand the universe. Einstein's theories of relativity, for example, build upon and extend Newton's laws, providing a more complete picture of the cosmos. Section 8. The never-ending quest, pushing the boundaries of knowledge. The study of physics is a never-ending quest to unravel the mysteries of the universe. From the smallest particles to the largest structures, there is always more to discover. Today, physicists are working on some of the most challenging and exciting questions in science. What is dark matter and dark energy? How did the universe begin? Can we unify all the forces of nature into a single theory of everything? These are just a few of the many questions that drive scientific inquiry. And while we may never have all the answers, the pursuit of knowledge is what makes the journey so rewarding. Section 9. Conclusion. The universe in motion. The universe is in constant motion, a grand cosmic dance governed by the laws of physics. By understanding these laws, we gain a deeper appreciation for the beauty and complexity of the world around us. From the simple act of walking to the launch of a rocket into space, physics is everywhere. It is the foundation of our understanding of the universe and the key to unlocking its secrets. So the next time you see an object in motion, take a moment to appreciate the invisible forces at play, shaping our world in ways both grand and subtle.